Welcome, ladies and gentlemen, to Project Development Module. And now, here we'll be looking at understanding climate change, and we'll be talking on the first lecture. Introduction. Climate change is one of the defining issues of our time. It is now more certain than ever, based on many lines of evidence, that humans are changing Earth's climate. The atmosphere and oceans have warmed, accompanied by sea level rise, a strong decline in Arctic sea ice, and other climate-related changes. The evidence is clear. However, due to the nature of science, not every single detail is ever totally settled or completely certain, nor has every pertinent question yet been answered. Scientific evidence continues to be gathered around the world, and assumptions and findings about climate change are continually analyzed and tested. Some areas of active debate and ongoing research include the link between ocean heat content and the rate of warming, estimates of how much warming to expect in the future, and the connections between climate change and extreme weather events. Lesson outline. Is the climate warming? Yes. Earth's average surface air temperature has increased by about 0.8 degrees Celsius since 190, with much of this increase taking place since the mid-1970s. A wide range of other observations and indications from the natural world together provides incontrovertible evidence of planetary scale warming. You can see in the diagram. How do scientists know that recent climate change is largely caused by human activities? Scientists know that recent climate change is largely caused by human activities from an understanding of basic physics, comparing observations with models, and fingerprinting the detailed patterns of climate change caused by different human and natural influences. Carbon dioxide is already in the atmosphere naturally. So why are emissions from human activities significant? Human activities have significantly disturbed the natural carbon cycle by extracting long-buried fossil fuels and burning them for energy, thus releasing carbon dioxide to the atmosphere. What role has the sun played in climate change in recent decades? The sun provides the primary source of energy driving Earth's climate system, but its variations have played very little role in the climate change observed in recent decades. Direct satellite measurements since the late 1970s show no net increase in the sun's output, while at the same time global surface temperatures have increased. What do changes in the vertical structure of atmospheric temperature from the surface up to the stratosphere tells us about the causes of recent climate change? The observed warming in the lower atmosphere and cooling in the upper atmosphere provide us with key insight into the underlying causes of climate change and reveal that natural factors alone cannot explain the observed changes. Climate is always changing. Why is climate change of concern now? All major climate changes include natural ones including natural ones are disruptive. Past climate changes led to extinction of many species, population migrations, and pronounced changes in the land surface and ocean circulation. The speed of the current climate change is faster than most of the past events, making it more difficult for human societies and the natural world to adapt. Is the current level of atmospheric carbon dioxide concentration unprecedented in Earth's history? The present level of atmospheric carbon dioxide concentration is almost certainly unprecedented in the past million years, which time modern humans during which modern humans evolved and scientists developed. The atmospheric carbon dioxide concentration was, however, higher in Earth's more distant past, at which time paleoclimatic and geological data indicate that temperatures and sea levels were also higher than they are today. Is there a point at which adding more carbon dioxide will not cause further warming? No. The answer is no. Adding more carbon dioxide to the atmosphere will cause surface temperatures to continue to increase. As the atmospheric concentration of carbon dioxide increases, the addition of extra carbon dioxide becomes progressively less effective at trapping Earth's energy, but surface temperature will still rise. Does the rate of warming vary from one decade to another? The answer is yes. And the explanation is that the observed warming rate has varied from year to year, decade to decade, and place to place, as is expected from our understanding of the climate system. These short-term variations are mostly due to natural causes and do not contradict our fundamental understanding that the long-term warming trend is primarily due to human-induced changes in the atmospheric level of carbon dioxide and other greenhouse gases. Does the recent slowdown of warming mean that climate change is no longer happening? The answer is no. And we explain that since the very warm year 1998 that followed the strong 1997 to 1992 98 El Nino, the increase in average surface temperature has slowed relative to previous decades of rapid temperature increase. Despite the slower rate of warming, the 2000s were warmer than the 1990s. A short-term slowdown in the warming of Earth's surface does not invalidate our understanding of long-term changes in global temperature arising from human-induced changes in greenhouse gases. If the world is warming, why are some winters and summers still very cold? Global warming is a long-term trend, but that does not mean that every year will be warmer than the previous one. Day-to-day and year-to-year changes in weather patterns will continue to produce some unusual cold days and nights, and winters and summers, even as the climate warms. Why is Arctic sea ice decreasing while Antarctic sea ice is not? We see that sea ice extent is affected by winds and ocean currents as well as temperature. Sea ice is the partly enclosed Arctic Ocean seem to be responding directly to warming, while changes in winds and in the ocean seems to be dominating the patterns of climate and sea ice change in the ocean around Antarctica. How does climate change affect the strength and frequency of floods, droughts, hurricanes, and tornadoes? Earth's lower atmosphere is becoming warmer and moister as a result of human-emitted greenhouse gases. This gives potentials for more energy for storms and certain severe weather events. Consistent with theoretical expectations, heavy rainfall and snowfall events and heat waves are generally becoming more frequent. Trends in extreme rainfall vary from region to region. The most pronounced changes are evident in North America and parts of Europe, especially in winter. How fast is sea level rising? We see that long-term measurements of tide gauges and recent satellite data show that global sea level is rising, with best estimates of global average rise over the last 2 decades centered on 3.2 millimeters per year. The overall observed rise since 1901 is about 20 centimeters, that's 8 inches. Now, what is ocean acidification and why does it matter? Direct observation of ocean chemistry have shown that the chemical balance of seawater has shifted to a more acidic state, that's lower pH. Some marine organisms have shells composed of calcium carbonate which dissolves more readily in acid. As the acidity of seawater increases, it becomes more difficult for them to form or maintain their shells. How confident are scientists that Earth will warm further over the coming century? Very confident. If emissions continue on their present trajectory without either technological or regulatory abatement, then warming of 2.6 to 4.8 degrees Celsius in addition to that which has already occurred will be expected by the end of the 21st century. Are climate changes of a few degrees a cause for concern? Yes, of course. Even though an increase of a few degrees in global average temperature does not sound like much, global average temperature during the last ice age was only about 4 to 5 degrees Celsius colder than now. Global warming of just a few degrees will be associated with widespread changes in regional and local temperature and precipitation, as well as with increase in some types of extreme weather events. These and other changes will have serious impact on human sciences and societies, and the natural world. What are scientists doing to address key uncertainties in our understanding of the climate system? Science is a continual process of observation, understanding, modeling, testing, and prediction. The prediction of a long-term trend in global warming from increasing greenhouse gases is robust and has been confirmed by a growing body of evidence. Nevertheless, understanding remains incomplete. All of these are areas of active research. Why are computer models used to study climate change? The future evolution of Earth's climate is as it responds to the present rapid rate of increasing atmospheric carbon dioxide has no precise analogues in the past, nor can it be properly understood through laboratory experiments. As we are also unable to carry out deliberate controlled experiments on Earth itself, computer models are among the most important tools used to study Earth's climate system. Climate models are based on mathematical equations that represent the best understanding of the basic laws of physics, chemistry, and biology that govern the behavior of the atmosphere ocean, land surface, ice, and other parts of the climate system, as well as the interactions among them. The most comprehensive climate models, Earth system models, are designed to simulate Earth's climate system with as much details as is permitted by our understanding and by available supercomputers. The capability of climate models has improved steadily since the 1960s using physical-based equations. The models can be tested and are successful in simulating a broad range of weather and climate variations, for example, from individual storms, jet stream meanders, El Nino event climates of the last century. Their projections of the most prominent features of the long-term human-induced climate change signal have remained reimbursed as generations of increasingly complex models yield richer details of the change. They are also used to perform experiments to isolate specific causes of climate change and to explore the consequences of different scenarios of future greenhouse gas emissions and other influence on climate. Are disaster scenarios about tipping points like turning off the Gulf Stream and release of methane from the Arctic a cause for concern? Results from the best available climate models do not predict abrupt changes in such systems in the near future. However, as warming increases, the possibilities of major abrupt change cannot be ruled out. If emission of greenhouse gases were stopped, would the climate return to the condition of 2,200 years ago? The answer is obviously no. Even if emission of greenhouse gases were to suddenly stop, Earth's surface temperature would not cool and return to the level in the pre-industrial era for thousands of years. Further, climate is inevitable. If emission of greenhouse gases continue unabated, future changes will substantially exceed those that have occurred so far. Thank you very much for watching.